No, not anything different than that. Like you mean like more forever? No, um, that is one of the solutions to the. I'll show you actually, but I just had never let it run that far. I think so. I just like wasn't even familiar with it. Um, but I first just wanted to review loops in general. So the thing that I think this is my son 2 years ago. um, he was helping me explain how loops work. So in the first one, I said run around the hoop 3 times. So that would be equivalent to a for loop. It's when you know exactly how many times you want to repeat an activity. So this activity is just running around the hoop. Um, and then anything in between the wrapper is going to be executed each time that it's executed. And the only trick is to make sure that you use the correct MATLAB syntax, which means that you have to put an array next to the for loop, and then the array represents how many times it'll run by how many elements the array has. So the array doesn't need to be 1, 2, 3, 4, 5. The array could just be random numbers. It could be like 6, 8, 50, and then it would just run for each of those numbers. And so I think that's what's a little bit confusing about the MATLAB syntax for loops, where while loops, the commands in between the wrapper get executed until a condition um, is no longer true. So the condition that you put next to the while loop tells when to run the loop, and then once that condition is false, the loop stops. So the equivalent that I have here for Burke is I said run around the loop until I say stop. So he didn't know how many times he's going to run around the loop, and then I said stop, and then he stopped. So those were the loops that we did, and we've also been doing if statements and actually applying them in the previous topic. And so remember that you can use any combination of if, else, and ends. And you kind of saw how you could do that in the previous lab and how there were actually several different ways you could have done that logic. And the way that I believe you guys both started is you had totally separate if statements that checked if end, if end, if end, which is an okay way to do it as long as rechecking another if statement couldn't like if the first if statement could change something and then the next if statement could recheck it, that could be a problem and you would need to use an else if. But if you were able to write if statements that were completely exclusive of one another, there would be no difference between the two. But some people still prefer else if just to know that for every one, only one of them gets chosen. So we also talked a lot about memory allocation, which we mentioned previously, but we went into further depth with it, and I showed you these 3 methods. One is just writing each element of an array V. The elements are 2, 4, 6. This one fills in each element one at a time with no placeholder for those elements to go, where method 2 starts off a V array and fills it with some dummy number, so zeros is a convenient way to do it, and then fills in each of the 3 numbers one by one. So this one is faster because it saves on allocating memory each time the loop runs, but the best method in MATLAB always is to use vector notation for definitions or any calculations, which would be this. So if you can find a way to find a pattern and use the colon operator, that would be your first choice. And then if you have to like hard code in each element, then that would be also an option. So here I've taken out the loops, but just wanted to show you how this is 4 ways to do the same thing. So let's say I had an array A that has 2 rows, and you want to multiply row 1 by row 2, and then take the mean. So one way to do that would be like kind of the loop mentality, which is to go to each particular element that you need to multiply them and save them to the equivalent element in another array B. And then once you get all three of them calculated, you add them up and divide by 3. You could even go one step back from this and not even save them to arrays. You could just save these to like B1, B2, B3. And so this takes a lot of typing. It doesn't necessarily take more work from MATLAB aside from reassigning the variable, but it's a lot messier. Instead, what you could do is you could do basically the same thing, but, oh, I didn't really explain this, but this is using single index notation, as you can see, instead of using double, and then this one's using double. So this one is even more confusing because you have to count in a more odd way. But then if you want to do one step better, you can access the whole rows and then do the dot multiply, which will do element by element multiplication. And then you could use some of the intrinsic functions like sum and length to actually do these types of calculations for you. And then finally, you can condense this all into one line where you just use the dot multiplication and the mean function. And you could combine this into one line too. But it just kind of shows you how many different ways there are to do the same thing. And what I always say at this point in the class is that I would much prefer you to be approaching a problem with a way that makes sense to you than just the best way, because this is doing a lot of things at one time. And so it's really at this point in the semester when students start kind of having a preference, and I would say like 95% of students prefer to do things in loops because they make more sense. They can like wrap their brain around what MATLAB is doing, even though MATLAB can do it much more efficiently. So that's why you'll see me suggesting both ways so often. I would say most people don't start vectorizing their codes until they've had much more experience. But being aware of it is really important so that you can read code. So I wanted to end with just talking about the algorithm a little bit that you guys wrote. So this is a really famous computer science algorithm called Conway's Game of Life. And if you type in life, I think, in MATLAB, the algorithm is already programmed in, and it's like it's a MATLAB Easter egg. We've talked a little bit about those. That brings up a screen that like has a graphical user interface of the game. And it was an algorithm that Conway came up with. I don't even remember. I didn't look at this, but you can go back and look at this link from Stanford. I pulled a lot of this from there, but I don't know what von Neumann did. Sorry, but I wanted to show you some of the features of the algorithm and just summarize the algorithm for those of you who might not have fully got it. So the idea of the algorithm is that you have an array. My array is called ARRT that has live and dead cells. And then you want to set up the algorithm to run as long as there are at least some live cells. So I saw everyone doing this. You have to take two sums to add up all of the elements so that you know how many are alive. And then that will be how many, that's basically your count, so I've used the variable living. And then the first outer wrapper is just a while loop that runs as long as that number is greater than 0. Inside the loop, there's going to be two for loops, and the for loops are going to just work through the grid in rows and columns. I used I and n for my indexes, so I is going to go through the rows, n is going to go through the columns. And for every element, it's going to count up all 8 neighbors, which is this line here. And then it's just a series of if statements that's going to check to see if all those conditions for reproduction and overpopulation and all of those are true, and either makes cells alive or dead. What I think the most common mistake that people make is they don't do anything to take care of what generation you're at, and so you want to save your array that before you start changing it, basically. So you can always look at the previous generation for when you're updating. So you'll notice that I have all underscore news for anytime I'm checking my array, and then I'm using the regular array anytime I'm updating. And then, like with all while loops, you need to make sure that you update the condition of the while loop at the bottom. Otherwise, the while loop never changes. So you can see that I have typed in the condition living equals sum. So if you didn't do that, it would always just run based off of the first condition. And then there's a plot in here just so you can see what's going on and seeing how it's changing. So the different things that you'll see in this algorithm are if you let it run long enough, one of the following of these patterns occurs. So these have all been named by people who have studied the algorithm, so you've probably seen all of them. Still life is one category, so these are cells that just stop, they don't change anymore, and there's these different configurations, they all have names. We saw a lot of these, the oscillators. These are ones that just oscillate back and forth between two still life patterns, and again, just been named like blinker and pulsar and stuff like that. There's also oscillators that travel, so those are called gliders and spaceships, which you probably saw in some of your solutions. And then there's one that's called guns, which just has like a pointed arrow that travels. It's also just a traveling oscillating pattern. And then if you start really getting into the algorithm and initializing it in the right way, you can see really kind of beautiful patterns that show up like these. And this is just like basically a whole area of research in math and computer science is understanding and like